Okay, so in this lesson, we're going to look at restrictions with regards to rational expressions. If you recall from a previous lesson, we talked about what rational expressions look like. So that's where you're going to have a polynomial divided by a polynomial. So these are all examples of rational expressions. Um, Now, what we're going to be interested in are examples where both numerator and the denominator may or may not have variables. All right, so again, a polynomial divided by a polynomial. And remember, a polynomial is defined to be one or more monomials. So hence, you'll see either one term or more terms, one monomial or two monomials. Two terms, three terms, and so on. Okay, so now in the previous lesson, we evaluated these rational expressions. So notice for each case, in these rational expressions, we substituted values for the variables that were in these rational expressions. Now, what we're going to do here is another important topic is the restrictions. What are the restrictions for these rational expressions, if any? They may or may not have any. And this is going to be important for next semester because when you graph these rational expressions next semester, you do need to determine where these rational expressions would be undefined. So let's talk about what we mean by undefined. So if you recall, if we have, let's say, 8 divided by 2, so we have this rational number, we can still consider this an expression. It's a numerical expression, but it's not a variable expression because there aren't any variables there. But it's a numerical expression. It is rational number. And 8 divided by 2 we know is 4. All right. Now what if you had 0 divided by, let's say, 2 instead? So remember, 0 divided by 2 is 0. Now if we have 2 divided by 0, if you take your calculator out and you type in 2 divided by 0, you're going to get probably the word error on your display, but basically you can never divide by 0. That is undefined. You can divide a number into 0, but you can't divide 0 into a number, so that is undefined. So whenever you divide by 0, that's undefined. So we're going to use this idea in today's lesson, the idea about dividing by 0. So let's look at a rational expression. So let's say we had this rational expression, and you want to find the restrictions of these rational expressions. And again, that's going to be important next semester when you graph these rational functions. So we're going to look at these in terms of functions next semester. So let's find the restrictions. So number one, let's suppose we had this rational expression, 2 divided by x minus 1. And recall in the previous lesson, you were told to evaluate this. Let's just kind of review the previous lesson. Let's evaluate this expression here if, let's say, x equal 5. All right, so if I let x equal 5, where we see the variable 5, I would substitute, where we see the variable x, I would substitute 5. So I get 2 divided by 5 minus 1, which is 2 divided by 4, which is reduced is 1/2. But what I'm interested in this lesson is determining what makes the denominator 0. What value for the variable makes the denominator 0? So I want to know, when is this denominator 0? Not the numerator, because remember, we can have 0 in the numerator. We just cannot have 0 in the denominator. So what makes the denominator 0 is what we're interested in. Now, for some cases, you could look at the denominator, that expression, and determine what value for x makes it 0. So if you look at this, what number can I substitute for x so that when I subtract 1, I get 0? Well, obviously the answer is 1. But there are cases where this won't be as simple. So what basically we're going to do is we're going to take this denominator, x minus 1, and we're going to find out where's the 0. That's the question. Where is that equal to 0? Well, notice that this equation that I just wrote, that's a linear equation. So to solve this linear equation, I'm going to isolate the variable, so I get x to be 1. So x equal 1 makes this denominator 0. 1 minus 1 is 0. So the restriction would be, in the blank, you would say the restriction in the blank would be when x is 1. So when x is 1, that makes the denominator 0. Now that fact is going to be important next semester. This is where we're going to start graphing these rational functions. So you're going to write this as a function next semester, and you're going to graph these, and that's going to be important. That restriction does mean something next semester. All right, number 2, let's suppose we had this rational expression. We have 7x divided by 3x minus 1. And again, I want to find the restriction. I want to find where is this restriction undefined. So where is it undefined? So it's undefined when the denominator is 0. So basically, I take the denominator. It doesn't matter what the numerator is. So notice I didn't look at the numerator over here. Although it's always equal to 2, it's never going to be 0 to begin with because there's no variable in the numerator. But there's a variable here, but that doesn't matter. I'm just interested in where is it undefined. Well, it's undefined when the denominator is 0. So all you do is just take the denominator, 3x minus 1, and find out where's that 0. You said equals 0. So notice this is a linear equation. So I'm going to get the variable x by itself. I'm going to isolate the variable. So I'm going to add 1 to both sides. And then combine like terms, I get 3x equal 1. Divide both sides by 3. I get x equal 1/3. So x equal 1/3 is going to make this denominator 0. That's what it is. And you can check it. Let's check to see if this is true. So I have my expression 3x minus 1. And where we see the variable x, I'm going to substitute 1/3. So I get 3 times x, which I'm saying is a third, minus 1. And remember, 3 times a third is 1. 1 minus 1 is 0. So that makes the denominator 0. So your restriction for this example is going to be when x is 1/3. So basically you're saying is that x cannot equal 1/3. That's what you're saying. You're saying here is that x cannot equal 1 because 1 makes the denominator 0 and 1/3 makes this denominator 0. All right, number 3, suppose I had this variable expression. Let's suppose we had 3 plus x divided by 5x. So 3 plus x divided by 5x. So again, I want to find where's this rational expression undefined. Well, it's undefined when the denominator is 0. So let's find the restriction. What makes my denominator 0? So again, if you need to, if you can't look at it and determine what the value of x would be, then you just set the denominator equal to 0. So just like the previous examples, this equation is linear. And notice that to get the variable x by itself, right now multiplying by 5, the opposite is to divide by 5. And so when I divide by 5 and I simplify, I get x equal 0 divided by 5, which is 0. And it kind of makes sense that in this case, x would have to be 0 because what's 5 times what is 0? Well, 5 times 0 is 0. So that's your restriction. So your restriction in this case is that x cannot equal 0. That's your restriction is. I can use any number, any other number for x. Any other number for x will be fine, except the only one that makes this rational expression undefined in this case is 0. Okay, so let's look at the next example. Oh, just to remind you, the reason why this one was 0 is because this is a monomial. So that's a monomial. This is a binomial. This is a binomial. So here, if that's a monomial and there's a variable there, then obviously it's going to be 0 because 5 times 0 is 0. All right, number 4. Suppose I had this rational expression, x squared minus 5x plus 4 divided by 6. And again, just as the previous problems, I want to find what makes the denominator 0. Well, if you notice right here, if you notice the denominator, that's just 6. Compare that with the other problems that we did here. This denominator is 5x, and this denominator is x minus 1. All of these problems had a variable in the denominator. Whereas over here, in number 4, there's no variable in the denominator. This denominator is constant. The denominator is constant. Is a constant term. Is a constant term. Okay, constant meaning that it won't change. It's always going to be 6. Here, this denominator, for example, is a variable term. These denominators are variable terms. Right in the word variable. So they vary. They change depending on what x is. If I let x be 1, I get a number. If I let x equal 2, I get a different number. If I let x equal 3, I get a different number, and so on. Whereas over here, like over here, if I let x equal 1, I get a 5. If I let x equal 2, I get 10. If I let x equal 3, I get 15. Notice it varies. It varies depending on what I plug in for x. Over here, though, no matter what I plug in for x, if I let x equal, let's say, 2, the numerator is going to be some value, but the denominator is always going to be 6. If I let x equal 4, I'm going to get something in the numerator, some value in the numerator, but the denominator is always 6. If I let x equal 3, I get a value in the numerator. The denominator is always 6, so it's always constant. That's what we mean by constant. It doesn't change. So again, this is always going to be 6. It will never be 0. Okay? Never be 0. It always 6. It is always 6 in this case. So when I ask for the restriction, so where's this rational expression undefined? What makes the rational expression undefined? What makes the denominator 0? Nothing. No value of x makes the denominator 0. There are no restrictions. So if I have x is not equal blank, you would say none. Okay? No value of x makes the denominator 0. Makes the rational expression undefined. Okay, it's always going to be 0. I'm sorry, it's always going to be 6. Okay, so it's never going to be 0. Okay, so number 5, we have 3x squared plus 6 divided by x plus 4 times x minus 1. Now, notice in this example here, again, I want to find the restriction, what makes the denominator 0. Notice in this example, I have a product of 2 factors. See, these are factors. X plus 4 times x minus 1. So just like you did in a previous lesson, when you solved quadratic equations by factoring, you want to find out what makes this denominator 0. So if I set each one equal to 0, I get x plus 4 equals 0 and x minus 1 equals 0. And so notice I went from this denominator that's in factored form to 2 linear equations. So there are 2 different values of x that will make this denominator 0. And so when I subtract 4 from both sides, I get x to be negative 4. And here when I add 1 to both sides, I get x to be 1. So these 2 values of x makes my denominator 0. So next semester, when you look at this in terms of a graph, you're going to notice something that's going to be different about this versus something different about, let's say, number 2, where there was only 1 restriction in number 2. In number 3, there are 2 restrictions. One is a negative 4, and the other one is 1. Because if I let x be negative 4, what's negative 4 plus 4? Well, it's 0. What's negative 4 and a negative 1? It's negative 5. 0 times negative 5 is still 0. So I get 0 down here. If x is 1, 1 plus 4 is 5. 1 minus 1 is 0. 5 times 0 is 0. I get 0 down there. So those are the 2 values of x that makes this denominator 0. And so your restrictions, depending on how it looks on my math lab, they're just going to ask you to state the restriction. So you would say negative 4, comma 1. All right. On the worksheet, it may say something like x cannot equal blank, and you would put negative 4, comma 1. Okay? All right. Now, number 6. You have x plus 7 divided by x squared minus 5x plus 6. X plus 7 divided by x squared minus 5x plus 6. Again, I want to determine what the restrictions are. I want to determine where is this rational expression undefined. What's undefined when my denominator is 0. So if you take the situations we had before, basically what we did to determine where that denominator is 0 is we set this denominator equal to 0 and we solve for the variable. So we set 3x minus 1 equals 0, solve for x, 5x equals 0, solve for x. Here, this did not have a variable, so it's always equal to 6, so there were no restrictions. This rational expression is never undefined. It's always equals 6. Here, to find out where this is 0, I set each of these factors equal to 0. Now over here, I want you to notice something. If I set the denominator equal to 0, just like this, notice what kind of equation this is now. This is a quadratic equation. So for right now, you're going to solve these quadratic equations by factoring. So let's go ahead and factor this quadratic equation. It is in standard form, so you have 0 on this side. So remember, you're going to end up using the 0 factor property. And so when I factor this into two binomials, I'm going to get, let's see, it'll be x minus 3 times x minus 2. All right, and then notice that looks similar to this one. So this right here, if you were to multiply this out, FOIL this out, this would be quadratic. So this right here would look like this. I mean, it'll be a different quadratic equation, but it'll be a quadratic equation. And so when you have this quadratic equation, remember you're gonna end up factoring. For us right now, you'll be able to solve this quadratic equation by factoring. Soon, your quadratic equations will not be factorable, so you have to use other methods. All right, and then basically use the 0 factor property. So if you have two factors whose product is 0, which is what this was, these two factors, so if you want to actually write it out, you would say x plus 4 times x minus 1 equals 0. So it kind of looks like this one right here. So if you have two factors whose product is 0, you're going to use the 0 factor property. So you're going to say x plus 4 equals 0, x minus 1 equals 0. And so over here you get x to be negative 4, x equal 1, which is what we had here. Same thing here. You're going to say each factor equal to 0, because remember, if you have two factors whose product is 0, the 0 factor property says one of these has to equal 0. So remember, a times b equals 0. So you have two factors whose product is 0, then either a is 0, the first factor is 0, or the other factor is 0. Same thing here. So x minus 3 equals 0, x minus 2 equals 0. And then notice I went from a quadratic equation to two linear equations. And so to solve this linear equations, I'm just going to isolate the variable. So I'm going to add 3 to both sides, so I get x to be 3. So that's one of your restrictions. Over here, add 2 to both sides, so I get x to be 2. So your restrictions, remember you're trying to find where's this rational expression undefined. Well, this rational expression is undefined when this denominator is 0. This denominator is 0 when x is 3. You can check. 3 squared is 9. 5 times 3 is 15. 9 minus 15 is a negative 6. Negative 6 plus 6 is 0. So your restrictions, you would say x cannot equal 3, 2. Those are your restrictions. On my math lab, you're just going to say, on my math lab, you're just going to fill in the blank. So you would say 3, 2. And it'll tell you to separate the values by commas. All right, and then finally number 7. Let's say number 7, we had this. 3 divided by 2x squared plus 5x minus 3. So again, if you want to find out where this rational expression is undefined, remember it's undefined when the denominator is 0. Notice though, this is a little bit more difficult to determine where this denominator is 0 because it's quadratic. This is a quadratic expression, the denominator. So I got to set the denominator equal to 0. And notice that I end up having a quadratic equation. And in a previous lesson, you learned how to solve a quadratic equation. And the way that we did it, for us right now, these quadratic equations are factorable. So you should be able to factor the left-hand side. So when I factor the left-hand side, I'm trying to find two factors such that when I multiply them together, I'm going to get this expression back. So when I factor this, you should get, let's see, I think this is going to be a 3 and this is going to be a 1. The last sign's negative, so that means these signs are different. And the one that works for the outer and inner is where the larger of these, the outer and inner, is positive. So that this outer 6x, the inner is 1x, so it has to be the 6x that's positive. All right, so it'll be plus and it'll be minus. Okay? All right, so then we're going to use the zero factor property next. And so the zero factor property says that if you have a product, if you have two or more factors whose product is 0, then you set each one equal to 0. So I'm going to set each of these equal to 0. So 2x minus 1 equals 0, and x plus 3 equals 0. And then I solve these two equations. So notice I went from a quadratic equation to two linear equations. And so I'm going to add 1 to both sides here to get 2x by itself. And then to get x by itself, right now multiplying by 2, the opposite is to divide by 2. And then when I reduce and simplify, I get the value of x to be 1/2. Over here, that one's a little bit easier. X would be negative 3. So those are two values of x that makes this denominator 0. And so your restrictions, you would say, x cannot equal 1/2, comma, negative 3. So 1/2 and negative 3 will make this denominator 0, which makes this rational expression undefined because you cannot divide by 0. Okay, so that's going to take care of this lesson dealing with finding the restrictions for rational expressions.